Welcome to qnawire.
This question said 20.0 milliliter sample of 0.2 molar hydroboric acid is titrated with 0.200 molar sodium hydroxide. So we are to calculate the pH after the following volumes of the bases have been added. A is 15.0 ml of the base. So if we write the equation of the reaction, we have HBr for sodium hydroxide to produce NaBr plus H2O. So the number of mole of the 0.220 ml is what? So that's going to be 0.2 divided by 1000 times it's going to be 20 divided by 1000. So we are converting the 20 ml to liters, then multiply that by the concentration will give us the number of mole. So this is 0.004 mole. So 15 ml of 0.02 molar NaOH will be how many moles? So that's 15 divided by 1000 times 0.02 or 0.2 rather, 0.2 times 0.20 is 0.003 mole. So from the equation of reaction, stoichiometry for the reaction is 1 to 1. So if we have 0.004 mole of HBr and we react with 0.003 mole of NaOH, we will have 0.001 mole of HBr left behind, right? And the total volume will be 20 plus 15, right? So that's going to be 35 ml. So 0.01 mole in 35 ml, concentration of HBr left will be 0.001 mole divided by 35 divided by 1000 liters. So this will be 0.0285 molar. Then pH will be equals to negative logarithm of that. And that will be 1.54. So B says if we had a 19.9 ml of the 0.02 of the 0.2 molar NaOH. Okay, so this will give us how many mole? So this is 19.9 times 0.2 divided by 1000. So this is 0.00398 mole. Okay, so we have 0.4. I'm just gonna write it again. NaOH plus HBr. We have 0.004 and here we have 0.00398. So what will be left after this reaction will be 0.00 002. Yes, 4 zeros, right? Yeah, mole of HBr, right? So we divide that by the total volume, which is 19.9 plus 20 divided by 1000, all in liters. So, and that will be 0.0005 molar. So that's the concentration of HBr. So pH will be negative log of this. So pH is 2.3. So for C, we have 20 ml of the 0.2 molar NaOH. So this is going to be 0.004 mole. And that is the same number of mole, which is the same number of mole for the acid, which is HBr. So the pH here, of course, will be neutral. So that's going to be 7.0. Okay. And then D is 20.1 mole of the 0.2 molar NaOH. 20.1 times 0.2 is 0.00402 mole. So if you have NaOH plus HBr, and this is 0.004, and here you have 0.00402, then we're gonna have an excess of sodium hydroxide. So will be equals to 0.00002 mole. So you divide that by the total volume. So that's going to be 20 plus 20.1 divided by 1000. So this would be 0.00049 molar. So that's the concentration of the sodium hydroxide. Then pH will be, or the pOH rather, negative logarithm of that. It's going to be 14 minus the negative logarithm of this answer. And that will be 10.6. Oh, sorry, pOH. Oh, okay. So this would be pH rather. Sorry. because I've decided to subtract 14 from it. Okay, so this is going to be pH is equals to 10.6. So the last one is 35 mil of 0.2 molar NaOH. So the pH here, first we need to calculate the number of mole, and that's 0.007 mole. And we're going to have excess of NaOH, of course, by 0.003 mole, right? That's because we have 0.004 mole of the HBr. So divided by total volume, 35 plus 20 divided by 1000 will give us the concentration. So concentration is 0.0545 molar. Then we can calculate the pH, and that will be 14 minus negative logarithm of 0.0545, and that will give us 12.736.